Hello everyone, welcome to online video lecture series developed by Jawaharlal Nehru Technological University Kakinada in association with Andhra Pradesh State Council of Higher Education. This is Dr. M. Prem Kumar, working as professor in the Department of Electronics and Communication Engineering, Sri Vishnu Engineering College for Women, Bhimavaram. Welcome to online video lecture series. In this lecture, we will discuss about autocorrelation and its properties. Autocorrelation. Autocorrelation is a special form of cross correlation or correlation. It is defined as the correlation of a signal with itself. So F1 of t equal to F2 of t is equal to F of t. So R of tau is equal to limit t tends to infinity 1 by t integral minus t by 2 to plus t by 2. This is F of t. This is F star of plus tau dt. Similarly, the same effect can be obtained by shifting limit t tends to infinity 1 by t integral minus t by 2 to plus t by 2 f of t minus tau into f star of t dt. Now we will discuss about the properties of autocorrelation. First property, autocorrelation for tau equal to 0 is an average power of the signal if f of t is a periodic signal. Autocorrelation function R of tau value is nothing but power of the signal if it is a periodic signal. That is R of 0 will be equal to t tends to infinity 1 by t integral minus t by f of t. This is f star of t as tau equal to 0. This is dt. And this is equal to limit t tends to infinity 1 by t integral minus t by 2 to plus t by 2. This is f of t mod f of t whole square dt, which is nothing but the power of the periodic signal. This is equal to p. Autocorrelation function value at tau equal to 0 for a periodic signal is nothing but the power of the signal. Similarly, for energy signals, autocorrelation function value at tau equal to 0 is nothing but energy of the signal. So that is R of 0 is equal to minus infinity to plus infinity mod of f of t whole square dt will be equal to E if it is a energy signal. If this is for power signal, normally all aperiodic signals comes under power signal and all aperiodic signal comes under second property. Autocorrelation function exhibits conjugate symmetry. Autocorrelation function exhibits conjugate symmetry. That is R of tau is equal to R star of minus tau. complex signal. So R of tau is equal to R of minus tau for real signals. So R of tau is equal to limit t tends to infinity 1 by t integral minus infinity, sorry, minus t by 2 to plus t by 2. This is f1 of t and this is f, so not f1 because this is autocorrelation function with itself, f of t and f star of t. Now you take complex conjugate on both sides, limit t tends to infinity 1 by t integral minus t by 2 to t by 2 f of t f star of t plus tau dt. So if you take complex conjugate on both sides, then what you will get is, so here you will get limit t tends to infinity 1 by t integral minus t by 2 to plus t by 2. So here you will get f star of t and this is f of t plus tau and this is dt. Now this is, and this can also be written as f of limit t tends to infinity 1 by t integral minus t by 2 to plus t by 2 and f star of t of beta. So this is nothing but r of r star of minus tau. So the r of tau is equal to r star of minus tau. This is for energy signals. Similarly holds good for power signals also. For real signals, r of tau is equal to r of minus tau. From this, we can conclude that real part of tau, real part of r of tau is an even function of frequency, even function of tau. Similarly, imaginary part of r of tau is an odd function of tau. So this is for normal complex signals. So another important property, third property, the maximum value of autocorrelation function R of tau occurs at origin. That is nothing but R of zero value is always greater than R of tau for all values of tau. So we will see the proof for this. Let us consider an integral I equal to limit t tends to infinity 1 by t integral minus t by 2 to plus t by 2. We'll take the one signal f of t minus f of t plus tau whole square. dt. Now if we expand this equation, limit t tends to infinity 1 by t integral minus t by 2 to plus t by 2. This is f1 square of t dt plus limit t tends to infinity 1 by t integral minus t by 2 to plus t by 2. This is f of t plus tau square dt minus 2 into limit t tends to infinity 1 by t integral minus t by 2 to plus t by 2 f of t, and this is f of t plus tau dt. So from this we can understand that this first part is this first part is a signal power. This is S1, and the second part is the signal power S, and this is the signal power S because this is not a cross correlation S, and this is S. With time shifted signal will not have any power variation. So this is equal to, and this is equal to autocorrelation function. And this is equal to S plus S minus 2 into R of tau, which is equal to 2S minus 2 into R of tau. So from the property 1, the power of autocorrelation function S is equal to R of 0. Hence, what we can say is that 2 into R of 0 minus 2 into R of tau is equal to I. So since this integral is always positive, as it is integral of a square function, and this square integral part is always greater than 0, so I should be greater than or equal to 0. And from this we can say that R of 0 is always greater than function value at tau equal to 0 is always greater than R of tau. R of 0 is greater than or equal to R of tau for all values of tau. Then next, coming to the fourth property, autocorrelation function R of tau of a periodic signal is always a periodic with the same period. This is R of tau plus T. So let us solve this. A periodic function, periodic signal f of t is expressed in frequency domain. F of t is equal to summation n is equal to minus infinity to plus infinity fn e power j n omega naught t dt. Okay, autocorrelation function of a periodic real function f of t is given by r of tau is equal to 1 by t integral minus t by 2 to t by 2. This is f of t, and this is f of t plus tau dt. Now substitute those values here. 1 by t integral minus t by 2 to t by 2 summation. This is fm e power j m omega naught t. So m is equal to minus infinity to plus infinity. This is with respect to x of f of t. So another one is summation and fn e power j n omega naught t plus tau. So n is equal to minus infinity to plus infinity. This is another part. And dt. So changing the order of integration and summation r of tau equal to summation m is equal to minus infinity to plus infinity, and summation n is equal to minus infinity to plus infinity. This is 1 by t e power j n omega naught tau integral minus t by 2 to t by 2 fm fn e power j m plus n into omega naught t dt. So if you simplify this, so summation m is equal to minus infinity to plus infinity, summation n is equal to minus infinity to plus infinity. This is fm, this is fn e power j n omega naught tau. And this value is, we can represent this as sine phi of m plus n by this phi of m plus n. Since m and n are integers, the expression given above is 0 except m is equal to minus n. That is, m plus n is equal to 0. So r of tau is equal to summation n is equal to minus infinity to plus infinity. This is fn and this is f minus n e power j n omega naught tau. This is equal to summation n is equal to minus infinity to plus infinity. This is mod fn square e power j n omega naught tau. So this is equal to f naught square plus twice of summation fn square. So n is equal to 1 to infinity. This is cos n omega naught tau, where omega naught equal to 2 pi by capital T. The above expression is periodic with a periodic function is t. Hence, it is periodic that periodic function has a periodic autocorrelation function with the same period. So r of tau is equal to r of tau plus capital T. So another important property, auto power spectral density that is S of omega and autocorrelation function of a periodic signals or power signals are Fourier transform pair. So R of tau and this is S of omega Fourier transform. So taking the Fourier transform of R of tau is equal to integral minus infinity to plus infinity. This is R of tau e power minus j omega tau d So substituting this r of tau value minus infinity to plus infinity, summation n is equal to minus infinity to plus infinity mod fn square e power j n omega naught tau into e power minus j omega tau. theta. Now changing the order of summation and integration, the Fourier transform of R of tau is equal to summation mod Fn square n is equal to minus infinity to plus infinity and integral minus infinity to plus infinity e power minus j omega minus n omega naught tau theta. So this is equal to 2 pi into summation n is equal to minus infinity to plus infinity mod Fn square to del of omega minus n omega naught. So in the right hand side equation is the power spectral density S of a periodic signal, signal f of t. Hence, autocorrelation function R of tau and the power spectral density function S of omega are Fourier transform pair.